I'm Michael Pappas, and this is a summary of lecture number 3, Specialization and Trade. Okay, for our previous lectures we've used the increasing opportunity cost model for the possibility production frontier, and that looks a little something like this. And it's a curved line which shows that for each additional unit you want, it costs more and more in terms of the other unit that you're getting. Now for the constant opportunity cost model, which we're going to use in this lecture, each unit is worth exactly the same no matter how many additional units you try to obtain. And that's described using the straight line. Absolute advantage versus comparative advantage. Absolute advantage means a person with absolute advantage can produce more than the other person using the same amount of resources. For this example, the only resource we're using is time. Say Michael and Jen are both producing t-shirts and pants within 1 hour. Michael can produce 5 t-shirts or 3 pairs of pants, and Jen can produce 3 t-shirts or 3 pairs of pants. 8 pairs of pants. Michael has the absolute advantage in producing t-shirts because if he focuses all of his efforts on making t-shirts, he can still make more than if Jen produced nothing but t-shirts. Jen would have the absolute advantage in making pants because Michael could only make 3 pairs of pants, and she could possibly make 8 if she devotes all of her resources. Comparative advantage is the ability of a person to produce a good at a lower opportunity cost than somebody else. For this example, Michael is making 30 t-shirts or 30 pairs of pants, and Jen is able to produce 30 t-shirts or 6 pairs of pants. First we have to find the opportunity cost for each person to make either a t-shirt or a pair of pants. Now, the opportunity cost of 1 pair of pants for Michael. Opportunity cost is always measured in the unit of what they're giving up. So we need to find out what Michael is giving up each time he makes a pair of pants. Alright, to do this, we take the amount of t-shirts he could make, 30, and we divide that by the amount of pair of pants he could make. And that gives us his opportunity cost, which is 1. For each pair of pants, he has to give up 1 t-shirt, and we're going to put that in the graph down here. We do the same thing to find out Jen's opportunity cost per pair of pants. So we take the amount of t-shirts she could make, 30, and we divide that by the amount of pairs of pants she could make, which is 6, which ends up being 5. So each pair of pants that Jen makes, she gives up 5 t-shirts. Alright, next we have to find the opportunity cost of 1 t-shirt for each person. Well, we could do the same exact thing that we just did, except put the pants on the top of the equation. For Michael, it would be 30 pairs of pants over 30 t-shirts, which would still give us 1. Alright? But an easier way to do it is just to take the reciprocal of the answer you got for the pairs of pants. So the reciprocal of 1 would be 1, and the reciprocal of 5 would be 1/5. And this is the opportunity cost for each person. In order to specialize and trade, each person has to figure out what they are best at, which means what do they have the lowest opportunity cost for. Alright, and in this example, Michael has the lowest opportunity cost per pair of pants. So that means he's going to focus all his resources on making pants, and Jen is going to focus all her resources on making t-shirts because she has the lowest opportunity cost for that. Alright, if each person were to work individually, Michael could say make 15 t-shirts and also 15 pairs of pants, and that would lie on his production frontier. Jen could make 15 t-shirts and 3 pairs of pants, and that would lie on her frontier. Now, each of them could make a different combination, but we'll just use this as an example. So without specialization, Michael would have 15 of each, Jen would have 15 t-shirts and 3 pairs of pants. With specialization, Michael has the possibility of making 30 pairs of pants, and Jen could make 30 t-shirts. Alright, without specialization and trade, Michael made 15 t-shirts and 15 pairs of pants, and Jen made 15 t-shirts and 3 pairs of pants. So in order for specialization and trade to work, each person would have to come out with at least what they could make on their own. So with specialization, the total produced was 30 t-shirts and 30 pairs of pants. That's between both Michael and Jen. So for them to trade, they would have to come out with at least what they could make on their own. Well, t-shirts, there was a total of 30 made, and each originally could have 15 on their own. So we can't see a gain in t-shirt production. But with the pants, Michael only made 15 on his own, and Jen only made 3 on her own. With specialization, there's a total of 30 pairs of pants divided between them. So Michael needs at least 15, and Jen needs at least 3. With trade, it could come out that Michael gets 20 pairs of pants and 10 pairs of pants, which is a gain over without specialization and without trade.